Okay, so for number 57, we are determining if these numbers are possible rational roots. And that is, of course, according to the rational root theorem. The rational root theorem, we have to look for p and q and then determine all the factors of p and q. So in this function, f of x equals 4x to the fifth minus 7x cubed plus 5x squared plus 15, our p-value is the last constant number, and in this case, p is 15. And our q is the first number, or the first coefficient of the leading term, in this case, x to the fifth of the highest power, which is a 4. We are then going to take the positive and negative versions of each of those factors. So the factors of 15 are plus and minus 1. 2 is not a factor. 3 is a factor of 15, so plus or minus 3. 4 is not. 5 is a factor, so plus or minus 5. And then we have no other factors until we get to the actual number of 15. So those are all of my factors of 15. For q, I really only have a couple of those. I have, of course, 1. We also have 2, and then 4. So we have 4 possible, or actually 8 possible factors of 15, the positive and negative versions, and we have 6 possible factors for 14, which are the positive and negative versions. So now we're going to see if we can get each of these values with these possible p's and q's. So in order to test that, we look for p divided by q. So if I take one of these values for p, let's take 1. Is 1 over 1 a possibility that I have for my choice? No, because 1 over 1 is 1. So then we could go to 3 over 1, and 5 over 1, and 15 over 1. And you will notice that 5 divided by 1 is a possibility. 5 over 1 is equal to 5. So therefore you will see that 5 is a possibility for this problem. So this is a yes. Okay? For letter B, negative 1/4, is there a way to get negative 1/4 out of p over q? And the answer is yes. We have a 1 here and we have a 4 here, and then we could make this negative 1 over positive 4. So negative 1 over 4 is a possibility. 3 over 2, again, do we have a p that's a 3 and a q that's a 2? The answer is yes. We have a 3 and a 2 here, so C is a possibility. Is there a possibility of getting 4? So is there something I could take and divide p by q to get 4? If I took 1 divided by 1, 3 divided by 1, 5 divided by 1, none of those will give me the answer of 4. Same thing with 3, same thing with 5, and same thing with 15. There are no combinations of p and q that will give me the answer of 4. And finally for E, we have 1/3. Is there any way of getting 1/3? And in this case, taking p and q to get 1/3, we have 1 over 1, 1 over 2, and 1 over 4. And we really don't have any other possibilities of being able to get 1/3 in this case. So again, the answer is no.